Today we're going to learn about scientific notation. Scientific notation is used to represent numbers that are very large or very small. It looks like this on paper. It usually says times 10 to the something power. In your calculator, you will never type in times 10 to the something power. You're going to use your EE. I'll show you that in class. Your calculator, when it is in scientific notation, reads like this. Okay, now let's convert decimals to scientific notation. Here's our decimal number, 75,100,000. The first thing you're going to do is underline your significant digits. Okay, we have 3 here, so our answer needs to have 3 in it once we convert it. Next thing, you find your decimal. We don't see a decimal here, but it's located right here. Okay? Now, we're going to move this decimal to where there's only one significant digit to the left, which would be right here, and we count. So we're going to go 1, 2, 3, 4, 5, 6, 7, because this is where we want our decimal. So I'm going to come over here and write 7.51. We have one number that's to the left of the decimal. And then we're going to say times 10 to the, and however many places we counted, that's what our exponent is. We counted 7 places, our exponent's 7. All right, now let's look down here. First thing we're going to do is count our significant digits. We have 4, so our answer must have 4 as well. Next thing we're going to do, locate our decimal point. We need to make sure that the decimal has only one significant digit to its left. So we're going to move this 1, 2, 3, 4, 5. That's where we want our new decimal. So 3.549 times 10 to the, and we move the decimal 5 places to the right, so it's going to be a -5. When we convert and we move the decimal place to the right, the exponent's going to be negative. If we're moving the exponent to the left, the decimal to the left, the exponent's going to be positive. Another way you can think of this is 75,100,000 is a much bigger number than 7.51. So this number up here has to be a positive number. If you look at these two numbers, 0.00003549 is a much smaller number than 3.549. So this exponent has to be smaller, or a negative number. Not smaller, negative. All right, what you need to do now is write all of this down in your own words in the spot that says to convert from decimal form to scientific notation. When you are done, I would like for you to do numbers 2 and 3 on your examples and then check your answers. Here are the correct answers. All right, now we're going to convert scientific notation to decimal. So this is in scientific notation and we need a decimal number. First thing we're going to do, count the number of significant digits. We have 2, so our answer has to have 2 as well. Now we have number 3 as an exponent. Locate our decimal point and we are going to move it 3 places. So I'm going to rewrite this, 1.1, and we need to move it 3 places. This number's positive, so this number will get bigger, which means we need to move the decimal place to the right. 1, 2, 3. Here's our new decimal place. Now, we fill in all of our extras with zeros. So our new answer is 1100. This has 2 significant figures. Our answer has 2 significant figures. Okay, let's go down here. 1.12 times 10 to the -3rd. Okay, guys, let's look at this one, number 3. The exponent is a negative number. That means that this number right here needs to become smaller when we convert it to decimal form. So I'm going to rewrite this so we have some room. All right. Times 10 to the -3. So I'm going to take this decimal and I'm going to move it to the left because it needs to become smaller. That's 1, 2, 3. Here's our new decimal place. Now we need to fill in our empty spaces with zeros. Okay. Typically we don't say 0.00112. we put a 0 in front, because remember, all leading zeros are insignificant. So here's our answer. These are the rules to convert scientific notation to decimal. I'd like for you to go ahead and write them down in that spot in your notes. And then I would like for you to do the other two remaining examples and then check your answers. Okay, correcting scientific notation. You need to move the decimal so that there is only one non-zero digit remains to the left of the decimal. You increase the exponent if you move the decimal to the left, and you decrease the exponent if you move the decimal to the right. So, okay, you're going to increase the exponent if you move the decimal to the left, and you decrease it if you move the decimal to the right. I'm going to give you an example here. 22.4 times 10 to the 5th. This is not in correct scientific notation because there are two numbers to the left of the decimal point. There should only be one. So I'm going to take this decimal and I'm going to move it over 1. So our new number is 2.24 times 10 to the 6th. I moved it to the left. I made it smaller. So I need to make this number bigger. All right, now let's say I have a number 0.145 times 10 to the 2nd. All right, I need to take this number, or this decimal point, and move it to where there is one significant digit to the left of it. So we're going to move it right there. So our answer is going to be 1.45 times 10 to the, now I made this number bigger, which means I need to make this number smaller. I moved it one place, I need to make it smaller by 1.